Hi, I'm a PhD student at the University of Chicago, and I'm here to tell you about some work I did while I was at Argonne on atJIT, which is a online optimizer for C++. So well over a decade ago, LLVM was proposed as a framework for optimizing programs throughout its entire lifetime. And by lifetime, I mean as a LLVM as a substrate so that you can use the framework throughout all the phases of compiling, linking, and then at runtime optimizing it on the end user system. So a lot of the left side of this figure has been effectively implemented in many production environments, but the right side of the figure is actually a bit complicated. And so atJIT's focus is on the runtime optimizer portion on the right there. So our goals for this runtime optimizer are that it's very easy to use. And for example, the goal would be just a single flag on Clang, and then we just get an executable that will begin automatically tuning itself. And so by online, I mean runtime. And so that's the main advantage over other work that was presented at LLVM in 2017. LLVM Tuner is an offline automatic tuning system, whereas this is done completely online on the end user system. So that lowers the barrier towards using it in many different systems. And we also tried to make it general enough so that other front ends can use it. Clang just happened to be the first one we decided it'd be easy to use it. So atJIT uses a Clang plugin that was originally developed in EasyJIT, which was shown at this past year's LLVM. And what it basically does is it bundles the IR for select functions into the binary, and then it links in our, and then we link in our automatic tuning runtime system, and the automatic tuning system will try to improve the performance by varying different optimizations applied to the program while it's running. So an autotuner, our specific autotuner will try to find settings for specific loops. We use the LLVM loop metadata, and we provide a stable numbering for all the loops. And then we can basically say unroll loop 1 however much, or don't unroll at all, for example. And we can also vary some other things like inlining threshold, etc. And then the search is the fundamental part of the autotuner, and what it does is it basically explores the space of configurations and tries to find ones that minimize running time. So we have three search techniques already available. We have simulated annealing. Random is just really for testing, but a good baseline. And then we have a custom-made tuner that I'm calling the Bayes tuner. It actually uses Bayesian optimization to help cut down the search space and navigate it more efficiently. I call it Bayes because it's not quite true Bayesian optimization, but it's pretty close. And I should have a paper on that sometime soon, or at least a preprint. Okay, so let's get into how to use it. Very quickly, if you have a function like this where you want to do matrix multiplication, you can see M, N, and K are fixed values, and you want to speed this up. The way you use atJIT is you create a driver, and that maintains the state of the tuning process. And then inside this loop here, every time you call reoptimize, it will try and return another function which has some instrumentation added to it. And so here, M, N, and K will actually become partially applied and inlined into the function before we actually JIT it. And so in this case, you'll either get back the best version that the tuner has found or an experimental version based on some configuration that the tuner thinks is the best one to try. Another thing we can do is tunable parameters. You can actually access the autotuner search to help you find out what the real good recursion cutoff for quicksort before switching to, say, insertion sort is. And the way you do this is when you want to reoptimize quicksort, instead of fixing the second argument to say 16, we say, we have a tune parameter, and you used to tell the tuner, hey, between 8 and 1024, you figure out the best version for this. And so as you keep calling reoptimize, it'll try and find the best version. And really quickly, so challenges in using LLVM, the biggest problem we had is canceling concurrent JIT requests because the autotuner tends to blow up code gen. and it's really ugly to maintain a mapping between Big Code and assembly, but I don't have much time to get into it. In conclusion, it's open source, you can use it, and if you're interested in GC StatePoint, come talk to me at some point. So yeah, thanks.